Up until now, the primary cost of solar cells has been the ultra-pure silicon needed for the photovoltaic reaction. But more than one company wants to change that.
The photovoltaics industry is based primarily on wafers of silicon to make high-efficiency solar cells. But those wafers themselves are very expensive. NanoSolar uses thin films of photoactive material instead of those expensive wafers.
Rather than silicon, NanoSolar in Palo Alto, California, uses a combination of semiconducting elements.
So you have copper, indium, gallium, sulfoselenide. Because that's obviously a mouthful, we get more work done if we just say CIGS, C-I-G-S-S. The beauty of the material absorbs sunlight very readily, so you can make a very thin layer.
So thin that the absorbing material is assembled on the nanoscale, then literally printed onto a foil substrate as a photovoltaic ink.
On this experimental machine, the foil is moving very slowly, but this style of machine can be made to run at tens or even hundreds of meters per minute. And because of this, these relatively inexpensive machines can be used to make an enormous quantity of low-cost photovoltaic cells.
Thin film solar panels, as well as their silicon counterparts, can be built right into a building surface, such as a roof, window glass, or in the near future, paint. So-called building integrated photovoltaics will drive down the cost of solar electricity even further.
Because you're not buying panels and the infrastructure, you're buying it all at once. And my lab has been looking at forecasts of getting 20%, 25% of total energy from solar by making it this ubiquitous material that you just get everywhere.